I'd like to, let me get back in the camera. Thank you. So I'd like now to call Professor Devek, and we would like to offer some closing remarks, and I'm furiously working on the scores, and we will also announce the lightning talks. All right, let me put this back on. That's it.
Do you guys have the slide deck? All right. Well, so while George crunches the numbers on the lightning talk, it's a pleasure to see all of you here. My name is Ollie Devek. I'm the Associate Department Head. And I'm going to shamelessly basically buy some time here for George. And I'm going to plug my journal during this time. So one of the really enjoyable things I've been able to do in recent years since 2022 is to be the editor of JSR, the Journal of Spacecraft and Rockets. And I want to encourage you guys to both read and submit and maybe even review papers. And I know for a fact some of you in this room have already done that. So let me tell you a little bit about JSR. All of the topics, by the way, that were discussed today in the panels, in the keynotes, and the student lightning talks definitely fall within the scope. So JSR is quite an old journal. It was started in January of 1964. And it's the second journal, along with the Journal of Aircraft, of the AIAA. And it's interesting when you know about the history of, by the way, who's an AIAA member in this room? Just show of hands. All right, wow, we have a lot of growing potential. If you are not a member of AIAA or a student member, you should be. Absolutely should be. It's a great society. It was started in 1963 as a merger of the American Rocket Society and the Institute for the Aeronautical Sciences. It's had one journal in 1963, the AIAA Journal, which is still with us. And within a year, it became very clear. Now, transport yourself into the mid-60s, a very active time, right, in astronautics, that one journal is not enough. And an AIAA journal got overwhelmed with many, many submissions. And so they said, well, we need more applied journals, one for space and one for air. And we're really honored. I mean, Journal of Aircraft, the editor-in-chief is Mark Drella, who's also in our faculty. So currently MIT sort of edits both of the more applied journals of the AIAA, and now there's 8 journals. JSR is published 6 times a year. You can see the scope here of the journal. So recent advancement in science and technology associated with spacecraft, tactical and strategic missile systems, but also including subsystems, applications, missions, environmental interactions, and space sciences. That QR code should work. We have been, so that means in 2024, we had our 60th anniversary, and we've been working on a really special virtual collection. So a virtual collection is a collection of papers on a certain topic. And this one here, we decided we want to go back to papers that were already published in prior decades that we felt had big impact, meaning, you know, these were ideas or theories that were published that led to actual flight missions. And the Mater team, where's the Mater team? You guys talked about landing on Mars. So the first one I want to mention, because it's a perfect segue from your lightning talk, is this. So I'm just going to give you a couple of papers that we decided to include in that virtual collection. So this is a paper from 1967. So this is before we even landed on the moon with humans. We had already landed robotically on the moon at that time. A gas bag concept for a stowable omnidirectional multi-impact landing system. And we actually used that for the first time for Mars Pathfinder in 1997. So if you do the math, that's exactly 30 years from when that paper was first published in JSR until we used that concept on a real mission on Mars, 30 years, okay? And that, can you imagine in 1967 that paper came out and these guys proposed to have inflatable bags and land on a planetary surface using inflatable bags? How crazy, how outlandish, how exotic is that idea? Well, maybe not. We did it. We used that concept. Of course, now we have Sky Crane, we have other concepts, right, for heavier payloads, as you guys discussed. But the point is, all those ideas that you are working on, ideas that were proposed and discussed at this conference, they may not be so crazy. They may actually be great ideas. It's just going to take several years. And if someone says, oh, in 3 years, we're going to land on Mars and do this, that's probably not going to happen. But but 10 years, 20 years, 30 years, this is a multi-decadal effort. And if you really want to make it happen, you have to be dedicated to that. Anyway, so I thought you'd be interested in to see this one. So then let's move 1 decade more or less ahead. Jeff is still with us, which is cool. This is a 1972 paper by a gentleman at Grumman Aerospace. And the idea here is a 120-inch large space telescope. So 120-inch, that's 10 foot, right? That's a 10-foot primary mirror diameter. And this became the Hubble Space Telescope. So one of the differences between this paper, this concept paper in 1972, Hubble was launched in 1990. Jeff, you've been part of several servicing missions. One of the differences is this is a 10-foot primary. The actual primary of Hubble is 2.4 meters, is an 8-foot. So they reduced the size of the primary mirror by 2 feet. But if you look at the graphic, a lot of the key elements, the primary body, the instrument module, the solar panels, it looks very, very similar to the actual Hubble that was launched. So that was a 1972 paper, launched in 1990. So that's only 18 years. Here's another one. 1993, this paper, Interception of Comets and Asteroids on a Collision Course with Earth. The idea that we could somehow deflect threatening asteroids using kinetic impactors. It's quite an old idea. I don't know for sure that this was the very first paper that proposed that in any journal, but we certainly proposed it. We certainly published that in JSR. And lo and behold, 3 years ago, 2022, this was demonstrated by the DART mission, a very daring, very exciting mission, Didymos and Dimorphos. Dimorphos is the smaller of the 2 asteroids that was orbiting and still is orbiting Didymos, but whose orbital period now has been substantially changed. It's the first time, this is a really big deal. This is the first time we as a human civilization have been able to actively change the orbit of a body. And it's a very significant milestone. And we were proud to publish that idea in the early 90s. And so here we're looking at about 19 years, right, between the idea and the actual DART mission. You're getting the picture here, right? 15 years, 19 years, 30 years. That seems to be roughly the time period. All right, now I'm really, really excited. George, are you getting there? Yes. Okay. Now I'm going to speed up, but I'm very excited about this one. So those were historical papers. This is the most recent, one of the most recent papers, and it's probably the most highly read or downloaded paper. It's open access. There's a QR code here. I absolutely encourage you to go take a look at this. This is a technical note that was published. It's a general velocity altitude flight regime diagram for aeronautics and astronautics. This is an updated version of a really old diagram that was first published by Eugen Sanger, an Austrian scientist, European scientist who made the original version of this. And it shows you on the y-axis the altitude above Earth's surface, and then the flight velocity relative to Earth. So we're going all the way from like Mach 1 to over Mach 60. And I keep joking, they're great places on this chart, except for the lower right corner. You don't want to be there. Anyway, the point of this chart is that in order to get to space and stay in space or come back from space to Earth, you have to go through this space access and return corridor. In the center, you see that circle with the white dashed lines? That is the corridor that anybody who wants to come back to Earth or escape from Earth has to go to. Beautiful diagram. You can download that. It shows you a lot. I mean, you can look at this diagram for a long time and still learn a lot. So to finish up and then ask George to come back and announce the winners, I wanted to reflect a little bit on today's theme, from the Earth to the Moon. And I see some parallels between lunar exploration and Antarctic exploration. So if you don't believe that Antarctic exploration is or was a precursor to space exploration, take a look at this picture. This is, there are several stations in Antarctica that are, some are seasonal, some are year-round. This is the second South Korean station. It's called Yangbogo, and was built first in 2014, but it's really high-tech. You know, it has satellite communications. It has a self-leveling mechanism, right, because the ice is always shifting. This is doesn't look so different from a real space station. So a while back, I made this diagram. I was wondering how many Antarctic missions have there been, and when did they happen over time? So you see here the cumulative number of expeditions to Antarctica, starting in 1820. So we had this initial, mainly coastal exploration, right? Antarctica was known as Terra Australis, right? Australis means the southern land. So 20 years coastal exploration, and then for almost 50 years, nothing, right? It's a flat line. There's almost no activity at all. And then in 1890s, many more explorations started happening. So there's this 50-year period between the initial exploration and when things really took off. So keep that in mind, right? 50 years, 1840 to 1890. And then, of course, you know, we had Amundsen reach the South Pole in 1911. 1925 is marked here. This was the American expeditions to Antarctica, the use of airplanes and radio and technology really enabling a permanent presence. And then 1957, the famous International Geophysical Year, when we had the handoff between Antarctic and space exploration as the ultimate frontier. So from the Earth to the Moon, that was today's theme for space tech. This is a diagram that you'll find on Wikipedia, and it's being constantly updated. The landing locations of landers, the different colors of the different countries. We haven't mentioned China a lot today, but I do think we need to give them credit, right, for the Chang'e program. It's a really impressive program, particularly landing on the far side. So in total, and I want to give credit here as well to Afreen and the project that she's been running now for over a year. And by the way, the fact that that program was continued, that project was continued and reassigned to a different office at NASA is a sign that this is a big deal. This is important. So the whole team there has been cataloging and looking at what have we actually landed on the moon. And landing sometimes means crash landing. It doesn't always mean soft landing. But in total, there have been 103 objects landed on the moon, and the total mass that we've landed on the moon is about 200 metric tons of human artificial, anthropogenic mass landed on the moon to date. But look at the shape of the curve. Do you see that? So there we go, 50 years between 1972 and 2022 when the curve really starts going up. So maybe, just maybe, the shape of that curve is not a coincidence. And we're about, we're about to repeat the pattern that we saw in Antarctica, but now on the moon. So give that some thought. So with that, just want to say final thank yous. First of all, George, we all know in this room that George is really the person who put this program together. George has been amazing, not just in organizing space tech, but also as an instructor now at MIT, his vision for Mars exploration. So let's give George a hand, please. Then a lot of people helped put this event together. So Marianne Carey in events, she's running our events at AeroAstro. Where's Marianne? Is she here? She's in the front. Let's give Marianne a hand, please. Janine Liberty and Rachel Orniz from Communications. Anthony, we see them back there. Anthony, hold up your hand. Karen, Bruce, Pam Fratkin, Kate Reynolds, and all of the AIAA staff. Let's give them a hand as well, please. Speakers and panelists, some of you traveled a far way. For some of you, this is a homecoming to MIT, which is cool. All the student volunteers, the chaperones, our sponsors and exhibitors, so the Aerospace Corporation, where are you guys? Aerospace, thank you. ANSYS, thank you. And Basalt as well, thank you. So thank you to our sponsors and exhibitors. I hope you agree this is an amazing facility, the Schwartzman College of Computing. I think this is either the first or second time we've had a big event here. The carpet still smells new. It's almost like still the fresh paint smell, but we love this venue. It's not far from AeroAstro, and I'm sure we'll be back. So thank you to Jonathan from the Schwartzman team, and then also you guys in the back, MIT AV and MIT Video Productions. Thank you. Finally, today was just one day in Massachusetts Space Week. We actually moved this event from March to April to not have two separate space weeks, right, at MIT and Boston and Cambridge. And we're really happy that we have a fully loaded space week now here in Massachusetts. Shout out to Alyssa and the whole Space Consortium team. And please explore, the Media Lab has an event tomorrow, the new Space Age Conference at Sloan. There's tons of events at the Museum of Science. There's the film festival. So if you're hungry for more space-themed topics, you will get your fill this week for sure. So with that, George, I hope this was not too long. And George will now make his announcements. So thank you, everyone, for attending today. And I hope you enjoyed it.
Okay, so while I have your attention, I'd like to just remind of a couple of things. Is this working? Did we run out of juice now? Oh, here we go. All right. So, okay. So immediately after this, we have the workshop for students in 33-206. I'm just showing this again in case some people were not here when I showed it before. And if you're passionate about space, this is a resume workshop unlike any other resume workshop you've ever been to. So totally recommend it. And there is also going to be potentially some SDK workshops, so bring laptops as well. SDK is the software for plotting orbits. So thanks again to our sponsors, and thank you to Basalt for the in-kind sponsorship and the support over the years of 16831. I'm very grateful for that. Yeah, so let's see who won the lightning talks. So there will be an honorarium for this. There is an award from the department. So we will, Marie, we will reach out afterwards to sort this out. And thank you, Oli, for that. So the second runner-up, I can also give you the average scores out of 7. So at 5.83, second runner-up is Daniel Monahan of Team Mater. Go 1683. The first runner-up at very close 5.91, so very little distance separating, is in the room, Patrick Riley. Congratulations, well deserved. You practiced, and it showed, right? The winners, and I have to say, you know, this is 1683 from 2 years ago all over again, when there was a tie between two teams, and we ended up having 2 projects in 1683. So there is a tie. There is a tie in 2 decimal places, if you can believe it. And there was a tie at 5.99. So, I mean, okay, you guys couldn't have given them a little more to make it a 6. So the joint first place, the winners of our Lightning Talk awards this year are Cesar Meza and Annika Thomas. Can I ask all the winners to come up on the stage for a picture? Runners up and the winners. Yep. Thank you. Congratulations. Yep. I don't have a check to give out now, but we will arrange it. Yes, it's on credit. It's an IOU. Congratulations. Please come through. Yep. All right. Congratulations. Right. So, okay. Can we? Yes. Maybe I need to put this back for the picture. How about that? All right. Picture. Yes. Thank you. Excellent. All right. Congratulations.